Today, I'm going to tell you about our science and engineering complex at Harvard University. It is essentially was designed to be one of the healthiest, most energy efficient laboratory buildings in the world. And also the same goes with climate resilience. Finished right around 2021 in a six-story facility designed by the Boston office of Danish Architect, which is a renowned architecture firm known for designing sustainable, innovative research buildings. It's a 544,000 square foot building, and it includes 70,000 square feet of public green space. And it is essentially meant to be Harvard's statement for the 21st century. You know, this is the building we need to be looking towards as we build more buildings and we retrofit our existing buildings on campus towards a fossil fuel free future. So just a little bit of background. So at Harvard University, when we talk about sustainability, we're talking about climate, health, and equity. We also have a climate action plan, which is focused around our goal in 2026, which is to be fossil fuel neutral. And that's after we've already reduced the campus by over 30% in emissions as of 2016. And our longer term goal is to become completely fossil fuel free. And there's some interesting components to this project that connect with that fossil fuel free future, because and essentially some of those things essentially mean that we're still learning on how we're gonna get there. So, but we're already thinking about it as we move forward. At Harvard, we like to think of our campus as a really great place to test new ideas, new ways of doing business. It's a great place to do pilot projects. And essentially that's the case because it's a very decentralized organization. Even for a university, it's sort of in a league of its own. It's also very large. We have 650 buildings total, 25 million square feet, two major district energy facilities, and we have 12 schools and so many leading faculty in sustainable research, technology, and design to help us along the way. Part of this is actually to learn from our faculty and students on campus. One of the ways we try to do that is to integrate what we call the living lab. And essentially that is where we use our campus as basically a laboratory, a research space for faculty and students to test their ideas. And we partner with multiple schools on that. And some of that is integrated into this project, the SEC. We also have a major part of this project was the integration of healthier materials. And I'll talk about that a little bit more when I talk about the certification of the project. But overall, Harvard was one of the earliest adopters of LEED certification. We have, I believe it's the most LEED certified projects of any institution in the world. And this project here is LEED Platinum. And also we have gone a bit past that into looking at other potential certification programs that I'll tell you about. And also just some background about this building in itself. The Harvard's located in the Cambridge and Boston cities in Massachusetts in the northeast of the US. Essentially our main older part of our campus is on the Cambridge side here. Across the river, we have our business school and our athletics area. Now we're essentially expanding into this Alston neighborhood of Boston, and the SEC located right here. And we have a lot more expansion over the next several decades, essentially building up a new hub for research and community. And this is just some renderings of that. Is essentially going to have mixed commercial office space. There's going to be a hotel conference center and residential space as well. So this building, along with the district energy facility, is meant to be the anchor for this new neighborhood that Harvard is building currently. So back to the SEC, Science and Engineering Complex. This is the home of the John Paulson School of Engineering and Applied Sciences. And essentially the school's essentially moving to this new building from its previous neighborhood on the Cambridge side of the river. The building has, like I said, a lot of cutting edge technology, world firsts, higher level numbers about the building. As far as the ventilation system is concerned, we use MERV 14 filtration along with a MERV 8 pre-filtration system. Total supply is around 190,000 cubic feet of air And yeah, essentially it's meant to be a positive impact on nature. And one of the nice things, if you're in the building and you're looking out into the neighborhood, these terraced green roofs, it's almost like the green roof will blend into the tree line. So it's almost like you're seeing a very green space when you're in the building looking out. And I'll tell you about this interesting facade as well. But first, a little bit more on the material side. So this was one of the main highlights of the project, because the idea is, in the US and in countries around the world, there are thousands of these products, chemicals and things, and only a small fraction of them have actually been tested for impact on human health. And there's a lot of evidence showing that there's certain classes of chemicals like antimicrobials, phthalates, and other substances that are directly impacting human health, and they're put into everyday products that we buy. And with this building, with the SEC, we wanted to really go through as many products as we possibly could. We evaluated over 6,000 products and essentially screened them for these toxic chemicals. And essentially, we're sort of making a statement towards the future. So anything from the furniture to the flooring, ceiling, all the way to like the mechanical rooms. Like you might find a technician that's repairing a network cable or working on plumbing, and those items are specially ordered without these chemicals, because they're essentially meant to say that we don't want these chemicals to be produced in the world for these reasons. Essentially because they're causing so many other problems, especially locally. So that was one of our major undertakings, and it's also part of the longer term life of the project, because essentially this part of that living building challenge that we're looking at doing, or that we did with this project, where essentially it requires you, unlike other certification programs, where you have to really stay with it and continue operating a building in a sustainable way. So like I said, PVC-free pipes, sustainable wood products, no formaldehyde, everything is essentially red list free, and so on. So this is a photo from the lab space. I like to talk about, this is actually the area where I worked on mostly for the project. I'm more on the retrofit side, existing buildings person, but I got involved in this project specifically because of the point that Stefan brought up earlier, which is the laboratory ventilation air changes. So at Harvard, we developed over the past 4 or 5 years, myself and along with a team of industrial hygienists and safety experts, and we essentially developed a new risk assessment program that is Harvard first, and we actually utilize a piece of research equipment to do this real-time quantitative inhalation risk assessment. It's actually a sort of an atmospheric science sort of device that it uses spectroscopy, and we can characterize, worst case scenarios and things like that. So it's very different than an on-demand ventilation system, but for us, we like it better because it gives us a lot more, understanding of what's actually happening at the bench, and we get those readings right up close. And I could talk about that project at length. I actually gave a presentation on it last week for the International Institute for Sustainable Laboratories. That's a great organization too, by the way. If you're looking to learn more about these types of topics, I'm very involved, and like I said, I talk about this project quite a bit with I2SL. But essentially, the idea was to make the building very plug and play with exposure control devices. So essentially, every bench has a tap where you can directly tap into a new exposure control device. So it allows for a lot of flexibility within the research, not limiting the science, but also maintaining those lower air change rates.